Hi, my name is Mike Bradeen. I work for Sangoma and used to work in support. Now I'm working on the Asterisk dev team. And today we're here to talk about load testing Asterisk-based PBXs with sipp. So let's go ahead and get started. So first question, obvious question is why load test, right? So we want to make sure that our system can handle a required threshold meaning call rate, number of calls, number of extensions. We want to ensure that the network throughput is sufficient. So we want to make sure our LAN side can handle it. Are we running different subnets? Can our switches handle it? Usually more important is our WAN side. Can our connection to our trunks work? Is that enough throughput for the audio? We want to have the chance to optimize the dial plan and applications. Is our queue working? Is that putting too much CPU load on? Should we be using a ring group? Things like that. But most of all, our real goal is to reassure our end users, right? So we want to be able to give hard data to them to say, hey, look, we run it. Here's our data. Here's some sample calls. Here's how it sounds. Right? So what is sipp, and why is it so useful for this? So sipp is an open source test tool created under the new general license, and it's used to simulate sipp user agents. sipp contains basic UAS and UAC scenarios. But more importantly, it allows us to script specific scenarios, which are written in an XML format. Adding additional variables from CSV files makes these scenarios more flexible, which improves automation. Support for out-of-scenario secondary scripts and automatic responses for info, notify options, and update messages further increases that flexibility, and it allows our sipp instances to act more like sipp user agents. You can see the following link if you want to download sipp. And also other documentation. We'll talk about some other features. RTP echo, pcap playback allows features for realistic media simulation. And with the use of secondary analysis tools like htop, TCP dump, and Wireshark, we can get a real good sense of how the system performs. Summary screens and logs indicate failure rates, giving us a sense of how the test ran, but not necessarily the quality of the particular calls. We also don't necessarily care about specific sipp instances failing. We more care about how the system does. Right? So capturing traces from the simulated user agents helps us quantify things like jitter and packet loss. We can always have sipp simulate load while we simultaneously make some sample human calls. This is especially useful as the human experience is the most important metric. Right? So just because we're using sipp to simulate trunks or extensions doesn't mean that we can't also use real trunks and extensions at the same time. So when we say trunks are easy, extensions are hard. What does that mean? So simulating a trunk is relatively simple, right? FreePBX, most other Asterisk-based PBXs define a trunk based on an IP or host name and port. And combined with IP auth and the AA flag, our trunk simulators can be relatively simple UAC, UAS scenarios. So before we mentioned how the automatic responses to infos, notifies, updates, this is enabled with this AA flag. So how does sipp work? sipp binds to specific IP and port. So we may need to create multiple trunks to different scripts if we intend to simulate inbound and outbound traffic simultaneously. But alternatively, we can use the match permit setting on PJ-sipp trunks. Rate, ramp up, and max simultaneous calls are all based on command line arguments, but these can also be adjusted on the fly, either via the standard in from the console that you're on, or by echoing commands to a particular UDP port. So in this case, right, the easiest way to simulate load would be to have a trunk in and a trunk out, with calls directly routed from the inbound trunk to the outbound trunk. This can be useful if we want to determine the maximum input and output, but this does avoid the load associated with having expected number of extensions registered or the overhead of things like ring groups and queues. Still, this method can be helpful for production PBX, where we don't want to take the place of existing extensions and only want to add call traffic. So what does that mean? It means you've got a system that's in production, it's in place, it's already configured, but you want to see how it can handle additional load or at after hours time, how it can handle load in general. So you can use this method on that system without interrupting existing routes, without replacing existing extensions. So let's take a look at what that would look like on a FreePBX system. the first thing we're going to do is we're going to create an IP auth trunk to our sipp test host. You can use registration. You could set up your trunk to do that, but generally, the overhead of the registrations very small compared to the rest of the test. So, and a lot of providers now are going to IP auth, so it's still reasonable to do it that way. If we look at our trunk, it's PJSIP trunk. Pretty straightforward. We give it a name. We give it a caller ID. On our next page, we can look at the PJSIP settings. You can see here that we've disabled authorization. Right, we've specified straight out. We've specified an IP, the port, and we're using our default context and transport. So once we've got our trunk set up, we need to set an inbound route so we can create that loop through. Basically, what we're going to do is route. In this case, we're routing on caller ID. You could route on DID. You could route on combination of both, however you want to do it. But the important point here is that our destination is back to our trunk. And if this is a system that's already in place, it's important to use. Because we're simulating the trunk, we're not really even bound by 64 or local rules or anything like that. We can sort of make that whatever we want it to be. We can set up our inbound route to be whatever. So let's look at both sides of that. The first side is going to be the UAS side. So you want to start that UAS scenario first. Right? So it's up and it's running. It's waiting for calls to come in before you start making calls. Break this down. sipp-sf. SF is the scenario file. You can hear I'm using sipp 3.6. I put it in subfolder within there. If you look at the name of our script, I try to name based on what it does. So in this case, it's a UAS scenario. So I start with UAS, ATSC, Astracon. In this case, it's a G711 pcap playback, which we'll get into later file. -I is going to be our local IP address of the SIP server that we're running on, and then a local port we're binding to, and a media port. And we're using that -AA flag so that we can handle any incoming info, notify options, updates without breaking out of our scenario. This will run. It'll wait for calls to come in at port 5060. And note that that's the port on the UAS side that needs to match our trunk. Right? So we're sending out our UAS needs to match the port. Generation side is not as important. Also note, if you note here on the bottom, there's a Google Drive link that we press down. All the XML files, all the scenario files, all the pcaps we reference here will be made available at that link. So after the presentation, if you want to go download those, try it for yourself, free to do so. So we're ready to receive calls. Now we need to generate calls. So once we're ready, we can start the UAC, making sure to specify the calling party to match the test route created. Right. So our route was routing based on call party. So we want to make sure that the scenario we use here uses the same call party number. Here we can see a sample command line, a UAC call generator that sends calls to specified IP port. So, in this case, it's the default port of 5060. So that's what PBXs is running. Please, the other thing to note here is that each CP instance runs on its own port. So we're binding this to port 5160 instead of 5060. So we're sending from 5160 calls to the PBX, calls back from the PBX to come back on 5060. And again, all this will be available for download. So let's break down those individual options. Right. So the first is SF, that stands for scenario file. It could be a local relative path or an absolute path. I generally use absolute path, but it doesn't have to be. The big advantage using absolute path is if you end up creating scripts that call your CP scripts, right? You usually want to use an absolute path. You see here, the first thing we specify is the PBX system under test. Notice that that is different from the UAS scenario because the UAS is just going to listen on the IP import. Doesn't need to know necessarily where the call is coming from. But in this case, because we're sending those calls out, we need to know where to send them to. So we need to specify that. And using our AA flag, that enables our automatic 200 OK for info, notify, options, and update. This is really important to use, because sipp is very strict in terms of the scenario that you spell out. So if you don't tell it to receive an info or notify at a particular time, it's going to break out of that scenario, and that call is going to be essentially broken. You can't necessarily control the way that these come in, so that's why we have this flag. So if you have this wonderful feature, it makes our lives a lot easier. -MP specifies our local RTP echo port. We'll get into that a little bit more later. -R, rate calls per second. M, number of test calls to run. Then our L's are limit or maximum number of simultaneous calls, and then our IMP for local IP import. It's important to understand the difference between M, MP, and RP, right? So R is a rate, it's usually in rates, calls per second, but you can specify RP to specify basically the denominator. So in this case, it's one call every 10 seconds. But you might not want it to just sort of do one call every 10 seconds until it's done. You might want to specify a maximum number of calls, right? So that's more typical. So in this particular case, you're setting one call at a time. We're going to use sngrep to watch this in real time on the PBX, close to real time. You can just do an sngrep. Any FreePBX system, 14, 15 later, should have it on it by default, but you can install it with Yum. sngrep-c will do just calls. If we look at the breakdown here, we can see that our IP addresses are obfuscated in this case because it's using public IP addresses. This is actually from a real test. And you can see that the call originated from 5160 to the PBX, but then the call that came back out was to 5060. So that matches what we did before on the US and the UAC page. Here's the detail breakdown of the individual call. So basically with sipp, you can use a space to select more than one dialog at a time. And once you hit enter to view, you can view all of them. So we see our invite comes from our UAC scenario. PBX like a trying, triggers a call back out to the trunk. Now our UAS responds with a ringing, waits 3 seconds, answers 200 OK. That gets passed back to the UAC side. UAC waits 10 seconds and then terminates the call. So that's our trunk scenario. So trunk in, it's a trunk out. It can be very useful for testing that WAN connection, and it also very helpful for putting the system under load without, with having a minimal impact on the rest of the configuration. So we said trunks are easy, but extensions are hard. Extensions are harder. Trunk is really just send calls to, receive calls from, that's it. Extensions are more difficult to simulate as they act as both the UAS and the UAC. So they're both the server and which requires separate scripts. Even if our only goal was to register then wait for a call, this cannot be done with a single script because the post-registration invite from the PBX will be considered a new dialog and would break the scenario. Okay, the -AA flag can handle non-call messages, but not calls. So to get around this, to simulate extensions, we're going to take advantage of sipp's OOCSF or out of scenario file feature. Okay. This lets us receive messages that are outside the scope of the scenario file and hand them to a separate scenario file. So I'm basically going to run 2 scenarios at the same time. This lets us act as a UAC for the purpose of registering with the PBX, while within the same sipp instance, again, it's important, act as a UAS that can receive new invite messages and respond to them as an extension typically would. Right? This is impossible with a one scenario. Sipp will treat the invite as a separate call, even if the scenario file expects it and will error out of the dialog. So what does that mean? It means even if you created a scenario XML file that did a registration, maybe had a pause and then waited for an invite, when that invite came in, it would be a different call. And so sipp would error out of that instance. It would iterate and start registering again, and that call would never get answered. The PBX would keep sending the retries on that invite, and basically it would just be an error failure scenario, which doesn't work. Okay. So again, we're going to be using 2 scenarios. The first scenario acts as the UAC, which registers with the normal 41, register 200 OK, then waits for a period less than the registration timeout. So that's basically all it does. It registers, and then it waits for a time that's less than that extension's registration timeout, and then the script ends, starts again, re-registers. So that basically acts as our registration loop. The -MN flag, so n is our number of times, so dash n flag, specifies how many times this loop will be run. Not how many calls we're going to take, how long it will run. So n times the wait period will determine how long the simulated extension will stay registered, but does not limit the number of calls it can accept. Okay, the sipp instance simulating the extension will pass all dialogues to the out of scenario file that are not already covered by the -a option. So our info, our notify, those kinds of things will get handled automatically, but new calls will go to the second script. Right? This is not a perfect reproduction, okay? And that the outline method does not cover subscriptions from BLFs, things like that, but the ability to register and accept calls is reasonably close. You could add more to the registration loops that did things like subscribe, things like that. But in general, this is enough to get a pretty good simulation. So let's take a look at how that actually works. So here's our sample CSV file. Basically just has two lines. One says sequential, which tells sipp how to read the entries and read the lines in the file. And then we basically got three entries. So the first one is our user extension. So if it's extension 200, you put in 200. PBX IP address, whatever the PBX IP, FTD, whatever that you're registering to. And then this special sort of set of keywords that we put together in the brackets here. So it says authentication, then username equals, again, that would be 200 be your extension, and then your password is the secret for that extension. And then here's what the matching registration looks like in the scenario file. Again, download the scenario files, take a look at the thing as a whole, but here it's important to break down how those fields match. So you can see field 0 is going to be the extension. It's in the from, it's in the to. Field 1 is going to be the IP address. Note that that's different from the remote IP, right? So the registration for that remote IP keyword that's in the first line, that comes from the command line. These don't have to be the same, right? If you're registering to an FQDN but sending to an IP address, but generally they're going to be the same. And then you've got our contact, and then under the contact you have field 2. Field 2, sipp will read that authentication special word and knows how to basically do the nonce response based on that. Okay. Reading this info from the CSV file has an advantage of letting our registration script be completely generic. Well, pretty generic. We can then create multiple CSV files and pass the CSV file to the scenario from the command line. So how does that look like? This looks like our previous trunk UAC. So we've got sipp, scenario file, PBX IP, and then -inf for the in file. We're going to specify the CSV file. The rest of it pretty much looks the same. Okay. And the other advantage is that this lets us simulate multiple extensions at the same time with the same script. So the only thing we need to change is the CSV file. We do, however, need to make sure that the local port is unique to each instance, so we don't have any collisions. So that MP, that P needs to change for every extension that you're running off of the same host. Okay. So if you're going to put this in a bash script, for instance, you're going to want to do that. If you're going to put it in a bash script, you're also going to want to put in some kind of pauses between the registrations. If you try to send 500 registrations at a time, you're pretty much going to cause the tap process to overload and break the box. But if you space them out a reasonable amount, it should be fine. So let's go look at those two scenarios. The second scenario file acts as a UAS, and that it waits for an invite, answers, and then waits for a buy. The scenario we use here sends a ringing and waits 2 seconds and answers the call. This can be modified to match the desired call flow. Want it to be longer, send ringing, send 180, whatever. It is even possible to use the distribution option to make the answer time variable. So instead of doing pause with a specific time, you can do pause distribution, and there's different distributions that you can use. This is just uniform, so basically randomly choose a value between 2 and 5 seconds, and that's how long you want to wait. This can be useful if the extensions are in a ring group or a ring all queue, and you don't want all extensions to try to answer at the same time, right? So if they all try to answer after 2 seconds, it's kind of like that's not really realistic, right? Generally, your agents who are answering the phone are going to answer over some sort of random period of time. So It is possible for the extension simulating side to generate the buy instead of waiting for it, but having the trunk side originate and terminate the call prevents area scenarios from leaving the trunk side instances hanging. Okay. As our goal is to load the system rather than test a variety of specific scenarios, encapsulating the call duration, rate, and concurrency to the trunk side simplifies the process and allows real-time modification of these variables in one place. Right. So we talked about before, you can make changes to the call rate, you can do plus minus, you can echo ports, you can automate all that. If you do that all to the trunk side, then you can sort of let the extension side be reactive and you don't have to sit there and do it. Again, like I said as well, so be very strict about breaking out of scenarios. So if we try to do the buys from one side and something happens, you're going to run into problems. If we go back and look at that queue example, not all the extensions are going to be able to answer. Some of those are going to be canceled. Those will be considered failures of that sipp instance, but they're not really failures. So we want to kind of leave all that control to the trunk side. And then again, please refer to the following link for details on how to change parameters on a running script. It's just documented really well in sipp source code. So note that it is possible to use a single host to generate your trunks and your extensions. If your system's pretty small, 10, 20 seats, you can get away with this usually, depending on the size of the host that you're using. But if you are going to use that, you want to make sure that username is before IP and your endpoint identification order for your PG-SIP settings on FreePBX. If you don't do this, basically, Azure can't really distinguish between the trunk and the extensions as well, and just will run into auth issues. So first, we're going to look at a brief SwitchVox example. So now that we're able to simulate trunks and extensions, we can put the two together and simulate real-world scenarios by having the trunks simulating UAC dial into the PBX and having the PBX route the calls to the registered simulated extensions. So using SwitchVox, this can be done with a ranged did rule that routes incoming trunk calls to specific extensions. And then we put a link in here for how to create a ranged call rule. We can then pass that list of dids to the UAC trunk instance as a sequential list, which sipp will then iterate through. And then again, here's our sample CSV. In this case, it's again sequential. Now, the numbers are also sequential. That's coincidence. Sequential just means read through the file sequentially. You don't have to. You can have sipp dial the numbers in a random order, things like that. And then if we basically look at the two line from our scenarios file, we can see again it's reading field 0. It's the only field that's in this file because we're just reading in the dids. If you don't know how SwitchVox range did rules, basically it's going to do some maths on those numbers. Generally, you're going to strip off the leading part of it, and then, so for instance, 2060, 2061, 2063 would be your extension. This is a really quick and easy way to generate bulk calls in, simulating a trunk, triggering a rule, and just walking through calling those extensions in order. Let's look at a FreePBX example. Okay, so queues are a very popular feature on FreePBX, but they can cause higher than anticipated load due to the additional overhead associated with queue calls. Right? So to test, we're going to create an inbound route based on the dids we passed in the script in the CSV and route it to a round robin queue. Okay, note that the did number is from the CSV, so we're feeding in. I just want to make sure that our inbound route matches our generation. Okay. We've got two extensions in the queue, 6506, 2010. Again, it can be as realistic as your queue actually is. It doesn't really matter. Reception of the out of scenario invites is pretty flexible. So then we're going to create two CSV files, one for each extension. Right, so we've got our 2010 CSV, and we've got our 6506 CSV. Again, we're using that sequential keyword, even though there's only actual one line of data. And you can see this matches the rule we specified earlier. So we've got for 2010, we've got 2010, put in the PBX IP address. I'm not including the real IP address here. Username is 2010, password is, again, the sipp secret. Okay, 6506, pretty much the same thing. We then start a sipp instance for each extension. Okay. And as you can see, right, our -p, our -mt are changing. They're 5160, 5161, 5162, if you were to keep going through this. It's important for the media port, you want to iterate by more than one, 2, 10, some even number. So, for the most part, it's a good idea to abstract the scenario file from things like did, auth, info, etc., by separating the information that can change from the actual file scenario. Right? The abstraction helps us in multiple ways. The scenario files can be reused between systems simply by using different CSV file at runtime. So we can have a bank of scenario files that we use, and we reuse those for multiple PBXs. It also lets us automate the generation of those CSV files. So there's bulk export, there's AMI, there's GraphQL, there's different ways to pull a list of extensions and secrets, and then you could write a script that would convert those into the CSV format that's appropriate for SIP. Multiple different ways to do that. It also lets us reuse the CSVs. So we can reuse the scenario files, but we can also reuse the CSV files. So let's say instead of a G711 set of calls, we're going to do 729, 722. We have different hold times, things like that. Maybe we want to cancel things, all those kind of scenarios. We can reuse those CSV files with the auth info and the DIDs, and then just change our scenario. Okay? So up until this point, we focused on simulating the SIP side. It's important, but it's not the whole picture. Right? This in and of itself is useful and helps us make sure our trunks and extensions are configured correctly, but to really simulate traffic, we need to add RTP. Okay? sipp contains an RTP echo option, which is similar to an echo test. Okay? This is controlled with the following command line options. So -RTP echo enables it. You can read here, just echoes those packets back. Pretty straightforward. MB specifies the buffer size, and NP is the port number that you're going to echo. Okay, this is useful if one side is a real endpoint, but having two endpoints just echo back at each other is basically useless, right? Neither side is generating; they're just echoing back and forth. But it could be useful if one side is generating audio or one side is an actual person. Okay? Instead, what we're going to use in this test is pcap playback. Right, a pcap playback feature of sipp allows us to take pre-recorded RTP streams and have the sipp script play back the stream as the RTP portion of the call. All right, we can use this in a variety of audio data. We can send white noise, which is really good for looking at just pure packet loss and gaps in audio. We can send DTMF tones, right? So if we want to actually have this dial in and navigate IVRs, we can use pre-recorded voice, which is our best all around. We can combine the three, right? So we could have some DTMF at the beginning to navigate the IVR and then generate human voice. And we can also have problematic streams, right? So if you've got a bad call that's got a lot of jitter or some echo or whatever it is, that could be useful. It's not necessarily falling under load testing, but certainly simulating a certain amount of packet loss or jitter could be. It's a good idea to have a few baseline streams for reuse, right? Keep those in your pocket. We've extracted a few based on public domain presidential speeches. Again, they're great. They're like half an hour of somebody talking. It's perfect. And they're available. They'll also be on my Google Drive link. Okay. So the first step is to actually capture a call containing the RTP stream in the appropriate codec. Appropriate codec is this can be done with Wireshark, TCP dump, Tshark, etc., whatever you want. If you're making one from scratch, make sure that the sipp user agent or the sipp user agent that you're using is configured to use the codec format that you want to test with. In this example, we're going to use a ULAW RTP stream. Okay, so in this particular case, how I did this was just using a microsip. And then I used some software to echo an MP playback of an MP3 file as the audio stream source. So instead of a microphone, it plugs into the software plays back the MP3. That way there's no, like holding a phone to a microphone. Well, you can do that. All right, so provided you've already got it, you open up the file in Wireshark, you go to telephony, RTP streams. Okay, now this is going to list all your RTP streams, right? You want to find the one that's associated with your call. This will list RTP streams that Wireshark found in the trace. From here, we'll look for the stream associated with our call, usually identified by the source and destination IP and port from the STP of the call. So we've got our invite. We should be able to know the IP address. We should be able to get the port. We should then come in here and see source address, source port, destination, IP destination port. That will give us our stream. Once we have it, hit prepare filter. That'll put a filter into Wireshark, and you'll just have the RTP stream you want. From there, you're going to go to File, Export Specified Packets, and make sure that you want to have displayed selected. Otherwise, you're just going to pre-export the whole file. Okay. So now that we've got a pre-recorded RTP stream, we can start playback of the stream using the play pcap audio action. So in the middle of our scenario file are going to be these lines. Okay? See, that's basically an action. It says execute play pcap audio. Again, we specify the pcap file, and if you look, this is the same name. That we saved it here, and that's it. But a few things to keep in mind with this is that the SDP offer in the sipp script should match the codec type. Usually, sipp user agents are going to give a couple of different codec types and let it negotiate. If we go back to that sngrep output we saw earlier, the reason I only specified one is because we want to force this particular codec. So even if the PBX responds with the list, we really want to try to keep it on the site and set the expectations. This is going to be a UL call. This is going to be 729 call, and then send it accordingly. The timing within the action of the script is also important. You don't want to start sending RTP before the SDP negotiation is complete. So do an early media, wait for that 180X exchange, or after 200. It's also important not to send it too late. If you wait too late in the call, you can trigger RTP timeouts, and the PBX will tear down the call. Okay. So, we've talked about how the generation side. Now there's also the monitoring part of it. Okay. We're not going to get too into that. That's really up to you. But basically, in general, we want to keep the system under test with SUT as close to the production or real world as possible. So try to run any network traces on the sipp test server or the network switch. Okay, both is even better. Taking the resulting captures from the sipp server also gives us a better representation of the output. We'll look at the end device, which is what's the most important. Right? The audio, if you're troubleshooting, what the audio looks like at the PBX is important. But if we're load testing and we're getting the user experience, it's really the trace at the user side that matters. So at the trunk side, at the extension side, that's the audio that really matters. Okay. And again, we're testing the whole system. We're not just testing the PBX, testing all of it. In addition, local monitoring tools like Zabbix, HTOP, running on the PBX can help give you a view of how the system is handling the load. CPO getting pegged, memory getting pegged, are you seeing IO wait time? If it's a VM, are you seeing steal time? You can watch that in real time and see how the system is doing. Multiple tools that you can do to record this as well. And then once you're done, the Asterisk full log is also very helpful. It is almost in some ways more important than the CPU information and IO information, where there are task processor failures, right? It's a sign, warnings, things like that, or a sign that Asterisk is reaching its limits on this particular PBX. Did any queues become unreachable during the test, right? Did we drop any extensions? Or was anything unable to keep up? These are things we want to look for. Okay. So let's go back to our beginning, re-examine our goals. Is this going to meet what we want, right? Well, any one part of what has been outlined here is useful. When putting them all together, we can really get a good idea of how the system will operate under load. When building our test, we remember why we're doing this and make sure that design testing is requirements, right? Are we trying to break it? Are we trying to see how it does in a reasonable load? Are we trying to see how it does in the worst case scenario? Run multiple scenarios, run through it multiple times. Build yourself a bank of data. Okay. We want to, again, make sure we can handle our required threshold, make sure the network throughput is sufficient. We can optimize our data plan as if we see any particular issues as we go through. And again, once we're done with this, we should have hard data, right? So we should come back to our user and say, here's the jitter we saw. And you also have audio recordings that you can extract from Wireshark, right, with Wireshark. Does this sound good to you? Is this acceptable? So thanks for coming and listening to this presentation. The following, here's the link. Again, I encourage you to go download those, make some changes. The other links were used here in generating some of this reference data. I encourage you to go check all of those out. Again, thanks for coming to the Mastercard meeting.